We need to do it at the factory. So today, I'm going to share with you on the metal.
Teacher, is it still learning metal?
Earlier, we learned about the melting point and also the melting point and the boiling point, remember, for different materials?
Yes.
So today, we're going to learn the melting point specifically for metal. Okay, which I haven't taught you yet. Okay, because different metal have different boiling point.
Depending on your project, melting point can play a key role in the material you choose. Anything from forging to high temperature applications can drastically change your decision. Online Metals is here to provide a quick walkthrough of the wonders of melting points. Each alloy and material have a range of temperatures, with the lower end of the range, solidus, and the upper end, liquidus. As you might guess from the names, when a metal is cooler than its solidus temperature, it's solid. When it's hotter than the liquidus, it's completely molten and liquid. But the temperature range in between is a strange space where the metal is both molten and solid. Pretty crazy, right? Different alloys have different melting ranges, as the elements in its chemical makeup change how easily it can melt. An alloy with a high percentage of tin or aluminum will melt at a much lower temperature than alloys that are mostly iron and nickel. Out of the materials Online Metals offers, aluminum alloys have the lowest melting point, ranging from about 848 degrees Fahrenheit, with some of the pure alloys to around 1230 degrees Fahrenheit for more advanced alloys designed for heat resistance like 7075. The copper alloys, bronze and brass, have a much wider range. Depending on the alloy, they will melt between the range of 1290 degrees Fahrenheit or 1900 degrees Fahrenheit. Bronzes, which often have more tin in them, tend to melt at lower temperatures than brass, which typically have copper and zinc. Pure copper melts at about 1980 degrees Fahrenheit. Steel and iron have the largest temperature range, and it really matters how much iron is in the alloy, as pure iron melts at about 2800 degrees Fahrenheit. Heavily alloyed steels or cast irons start to melt around 2050 degrees Fahrenheit, whereas lightly alloyed steels and certain wrought irons melt at about 2900 degrees Fahrenheit. Lastly, nickel alloys are valued for their high melting points and resistance to heat. Heavily alloyed nickels will begin to melt at about 2430 degrees Fahrenheit. More lightly alloyed nickels, or ones alloyed with specialized metals like chromium, will melt at about 2950 degrees Fahrenheit. You can also use the color of the metal to gauge how close you are to the melting point. Aluminum usually turns a faint red to blood red when in melted form. Copper, brass, and bronze range from a cherry red to a lemon yellow. Iron and steel alloys are usually ranging from yellow to white depending on the makeup, while nickels will be pure white when they're at their melting temperatures. Thank you for watching another Online Metals video. Please subscribe to our channel or leave a comment below with questions or future video requests.
Another one.
Okay, so let me explain the types
If
of
you've looked at
metal
a
first,
piano
alright?
keyboard in the past,
Okay, so there is many types of metals. Okay, let me show you the types of metals. All right, so they are gold, bronze, brass. Okay, so let's see over here. You can see many types of metal. The most common metal that all of us understand. Sorry. Okay. Okay, let's say the first type. Okay, the most common metal that all of us understand is gold. Okay, gold, that's where we have earring, we have necklace, all these are gold bars. Okay, because this is the most precious or most scarce metal of them all. Okay, that is metal, gold. Okay. when you get a trophy. So normally the first one that get the trophy, it's called gold. Then the second one, normally it's silver. Silver is the second most precious metal in the world. Okay, because silver is where, again, earring and all this stuff as well. So we have silver coins and all this as well. Okay, so coins, all these are made of silver. So these are the two most precious ones. And the third place, normally the third place medal, it's made out of copper. Okay, copper, it's like a little bit brown, a little bit on the brown color side. Okay, so copper is also used in the wire because metal are very good electric conductor. All right, so normally you see copper inside wires. Okay, so that's pretty much copper. Bronze, nowadays there's more bronze, how to say, bronze accessories. Okay, like sometimes you can see bronze teapot and all this stuff as well. Okay, it's because it's shiny and it's smooth. All right, so this is bronze. Bronze color, it's about like copper, but it's way cheaper. Okay, what some people also call it something like a rose gold kind of thing. Okay, rose gold is basically a mixture of gold and bronze. Okay, brass is a metal that hardly rust. Okay, that's why it's normally used for doing the water pipe. Water pipe. Okay, because water pipe, like for example, you want to shower hot water, right? When you want to shower hot water, the heat, cold, hot, cold, hot, cold. So normally, if you use plastic, the thing will spoil. Okay, because the heat, the hot water will melt the plastic. So they use metal. What kind of metal which is the best? Normally they use brass. Okay, so besides that, like nails and screws, normally it's made of iron. Mercury is very sensitive a little bit. That's why it's very fast become very sensitive to the heat. That's why normally the thermometer we use mercury.
Teacher, mercury is dangerous stuff.
Yes, it's poisonous and dangerous. So don't break your thermometer and then drink that red color dot. Okay, that is mercury. Okay, it's poisonous. Okay, answer your question. Okay, tin, this is where our can and everything made of. Okay, it's made out of tin. Okay, lead or lead. Okay, this is where our pencil lead, that is what it's made of, lead. That's why it's black color. So these are all types of metal. So different metal have different melting point. Okay, different metal have different melting point. Okay, can all of us turn to page activity book, page 31. Activity book, page 31. What happened? The activity book, page 31. Okay, page 31. All right, so in this activity, you use the information in the table to compare the melting points of different metals. Okay, question number 1. What is melting point? What is melting point?
Let the things melt.
Almost, almost, almost.
Almost.
Point. Point is a temperature. Okay, it's a temperature where it changed from what to what state? From what state to what state? Solid, liquid, gas. It changed from what first?
Liquid.
Okay, from liquid to
From liquid to gas. From
liquid
solid
to gas.
liquid to gas.
From what to what? What to what? Okay,
Solid to liquid.
fantastic. Okay, look back. Yes, last week you draw a chart. Remember the process, the three process. Okay, the three state of matters with 6 processes. So when you see the word melting, melting is where the temperature at which solid turns to liquid.
Liquid.
Okay, as long there are 3 keywords here, it is a temperature, solid to liquid. If I see these 3 keywords, then your answer is correct. Got it?
Body.
What is melting? Melting is turning a solid turning to liquid. But what is melting point? When I say the word point, you have add the word temperature. Okay. Now, list the metal in order of highest to lowest. Which is the highest here? Harold, which is the highest melting point? Means the hottest.
Copper.
Very good. Okay. Can you type on the screen? Can you type directly on the screen? Highest to lowest. Ask him to type go and write number 1, 2, 3 there. Okay then. Okay. Just now you say copper is number 1. Now why the other way around? Think you just told me copper first. Copper to highest to lowest. Okay, so copper, then gold, then
Oh, you said that. Okay, no.
you said one thing, but you write another thing. So funny. Copper, gold, silver, aluminum. Then complete the following phase change. Gold, Original was what phase? Solid, liquid, or gas?
Solid.
Fantastic. After it go through what? Very good. Please write down. Fantastic. And then the gold will turn into liquid. Good job.
Teacher, what Jensen write question 3?
Yes, correct.
What is the second?
Second, copper, gold, silver, aluminum.
Sun and 64.
Over here, see gold. Gold melting point is 1064.
1064.
That's right. That's right. Done. Okay.
A few months ago, a patron of mine contacted me because he saw one of my old videos where I separated gold from computer parts. He was wondering if I could do a video like that again, except on jewelry, and he wanted to send me some gold-covered chains and an old Rolex. He had no idea how much gold was actually in any of it, but he was pretty sure there was a decent amount. I thought it would be fun to pull out whatever was there, even if it weren't very much, but I did have one concern. Before this, most of the chains, though, were really heavy and felt way
Okay,
too
so
dense
now
to
I'm
be
showing you a video how they change the gold at your house. It's like, I don't know if it's real or not. So they're gonna melt it and then they're gonna turn into a gold bar. How do you melt the gold from your jewelry into gold bar?
Get the melting point.
made from any of those metals. When it was all organized,
So
I
the
saw that
best
I had
part is
5
that you can do it at home. How do you get 1000 Celsius at home? How do you do that?
chains, a watch face, and a bunch of scrap stuff. The first thing I did was take a look at the watch, and I noticed that it was still working. The fact that it was still functional, and that it probably didn't have much gold or any other precious metal in it anyway, I really didn't think it was worth destroying. So I put this on the side and I moved on to looking at the chains. The first thing I wanted to know. This is why, even after sitting here for a few minutes,
Okay.
pretty much
So you see, if the chain there is written there, 18K gold, those are real gold. Then you can stop.
nothing happened. A deep scratch also didn't do anything either, so together, this told me that not only was it not plated, it was probably at least around 14 karat. Now, using the same test with a piece of the smaller chain, it was a different story, and the acid immediately started attacking it. It also changed colors, where it was initially blue, and then it slowly shifted to being green because of all the
Okay, so this is a test whether is it real gold or not real gold.
copper nitrate that was forming. About 10 minutes later, there was almost nothing left, and it was mostly just some light black flakes. From this, I took a small sample, and I added it to a test tube. Then I diluted it with some more water, and I added some concentrated hydrochloric acid. And almost immediately, a whole bunch of white stuff appeared, which was probably silver chloride. This told me that, well, there was silver present, and that the chain was probably just a mix of copper and silver. The last thing to look at was all this scrap, but I didn't bother testing it because none of it felt very dense at all. I just assumed that it was all less than 14 karat, and I decided to process it separately. For now though, I put it aside, and I went back to working on the chains. I now had an idea of how much gold was in each chain, and I knew that this one probably didn't have any gold at all. I decided that I would still process it though, but I would do it with all that other scrap stuff. To process these chains though, which actually had gold in them, the next step was something called inquartation. This just meant that I had to mix it with another metal like copper or silver to knock down the gold concentration. Typically, the target is some torch heads, like the one I have on the right, are made of brass. For general use, this is totally fine.
The texture
Is everything all right?
is crispy.
Am I
Fine, but in this case, the tips of the torches are surrounded by insulation. This causes them to heat up way more than normal, and with brass, it can start releasing toxic zinc vapor. For this reason, I did it all in a fume hood, but I probably should have just avoided brass altogether. My torch head on the left is made of steel, and I could have just gotten another one. But anyway, after 15 minutes or something, it didn't even look like it was close to being red hot. I honestly wasn't very surprised by this, and I assumed it was because the can and the crucible were way too big for these small flames. The simple solution to this was to just build it using a smaller can.
Wow,
The one
using
issue
a
with this,
can, you can make 1,000 cells inside.
though, was that the only crucible that I had that would fit in this was made of graphite. I wasn't sure if it was okay to use with torch flames,
Graphite
but I
is a kind of
figured I'd give
stone.
it a try. I did a test run and I was able to get it red hot, and it didn't look like it was getting destroyed by the flame.
Okay, you need a
So I
very
let it cool
strong
back
type of
down to
stone
room
so that
temperature, and I
it
started
can
loading it
withhold
up
the
with
heat.
copper and the
So
chains.
graphite is a kind
It
of
only had
very
space,
strong
though, to
stone.
fit one chain and its copper, so I'd have to wait for it to melt a bit before adding more. So I put this inside my little can thing, turned on the torches, and covered the top. Within just a few minutes, it already started glowing red, and to get it going faster, I blasted the top with another torch. Then I let it sit there for a little while more, and it eventually started to melt.
See,
There
the
was still
gold turned from solid to liquid.
Wow.
a bunch of solid stuff left in it, but it was liquefying. There was now a lot of extra space, so I started
And
adding
when
more copper and gold. I
the
started with the small
stone
14 karat
become
chain
red
and all of
color,
its
right?
copper, and it might have looked a bit weird here. And this was because, to make sure that there was no moisture on any of the metal, I preheated it with a torch. I really blasted it a lot though, and the chain melted a bit into the copper. I waited for all this to melt, and then I added half of one of the larger chains, along with half the amount of copper. It very well might have been possible to do the whole thing, but it didn't really make much sense to try. There was still a third chain to do, which definitely wouldn't have fit, and it made no sense to risk overflowing it if I had to do a second run anyway. But in any case, with everything added, I covered the top again, and I waited for it all to melt. When it eventually all liquefied, I stirred it around really well to make sure that all the metals were evenly mixed. After that, I covered the top and I heated it for another few minutes just to make sure that it was nice and hot, and then I poured it all into a can full of water.
Do you want to touch that? No! Immediately go hospital if you touch that. Glowing.
When that was done, I dropped the crucible back in and I set up the second run. Just to make things go faster and to make sure that there was no moisture in it, I gave all the copper and the
You
gold
see,
chains
normal-
a strong
Normal
preheating.
burning, you just black.
Then I slowly added everything to the crucible.
Normally burning, you
At
just black, it
first, I
doesn't
just
melt.
did this with the
So you need
tongs, but I found that doing
1,000
this with all the
Celsius
copper
and
would take
only
forever,
enough.
so I just started pouring it in from a vial. It was a lot faster to do it like this, but it wasn't nearly as accurate, so I ended up missing with a bunch of the copper. However, this really wasn't much of an issue, because not including just a small amount of copper wasn't going to make much of a difference. When it all eventually melted, I mixed it around like before, and I let it sit for a few more minutes. I then went to pour it all into the same can, but I was a bit surprised because liquid metal started coming out from the side of it before the front. This definitely wasn't a good thing, but for the time being, it was still a bit too hot for me to investigate. So for the time being, I put the crucible back in the can, and I turned off the torches, and I let it cool. When I took a look at it a few hours later, I noticed that there were some huge holes in the side of it which were made by the torch flame. This is why you aren't supposed to use oxidizing torch flames
So
on
you see,
graphite for long
when the
periods of
graphite, the
time.
stone,
I
it
was
become
lucky it
black
didn't end up
already
being a
now.
problem, but it could have caused the crucible to break when
Even
I
have a
tried
hole.
picking it up. This could have not only caused all the gold to spill everywhere, it also would have been a huge safety hazard. But anyway, getting back now to what was thankfully not a catastrophic failure, all my gold alloy was now in this can. So I just quickly got rid of all the water, and this was what it was like. By dumping all the liquid metal directly into water, it created these pieces that have relatively high surface area. Ideally though, they would have been a bit flatter and looked more like cornflakes, but I think I just didn't pour it from high enough. In the can, just sitting on the fiberglass, I also found this chunk of alloy which had leaked out the side of the crucible. So I took this, along with all the flakes, and I put them in a beaker. Then, on top of all of this, I poured in some dilute nitric acid. A reaction immediately started, and some nasty nitrogen dioxide vapors started coming
so pretty
off.
now, right?
The nitric acid was attacking all the copper that I just incorporated it with, as well as any other metals that might have been mixed in with the gold. In this case, the other major metal that was used was probably just silver. There might have been small amounts of other metals though, like nickel, zinc, or iron. The nitric acid converted the copper metal to copper nitrate, which, like I mentioned before, has this really nice blue color. As the concentration of the copper nitrate increased though, it slowly shifted to being a dark green. The
Uh-huh.
silver and other trace
This kind
metals
of
are
chemicals
also
is
being
not
converted to
commonly
nitrate salts
available,
and getting
so
dissolved into solution.
can't do it at home.
The silver nitrate is colorless
Okay,
though,
unless
and there isn't
you
enough
are
of the other metals
certified
to really affect the color.
in
When the
chemistry.
reaction died down, I added another load of dilute nitric acid, and it started bubbling like crazy again. I waited for this to also settle down, and when it was
Ew.
done, I dumped everything into a larger beaker. I then kept adding more of the dilute acid, and I continued the same cycle. As I mentioned before, I'm using dilute acid here instead of the concentrated stuff, and there were two major reasons for this. The first one is that it stops the reaction from getting out of control, and the second one is that I needed the extra water to dissolve all of the metal salts that I was making here. A major effect of this though is that compared to the concentrated stuff, the reaction is slowed down quite a bit, which makes it take a lot longer. So to speed things up, this reaction needs to be heated, usually close to the boiling point. I didn't use a thermometer though, and I thought I was close enough, but I don't think I was. And because of this, it would initially react
So they are
quite a bit
keeping
when I
using
added more
induction
acid,
cooker.
but then it would kind of just stop. However, just by looking at the stuff at the bottom, I could tell there was still a lot of copper left. At the time, I thought that maybe the acid was just depleted, so I dumped off the liquid and I added new fresh stuff. The same thing happened again though, so I started getting suspicious. Just as a quick comparison, if we look at the gold to get it as maybe it could be interesting to add it dropwise. The moment I did, some brown gold powder started precipitating out, but it wasn't particularly interesting. So I ended up just scrapping that whole idea and dumping in the rest of it. The potassium metabisulfite is a reducing agent, and it reduces the gold in the chloroauric acid, and I also added some sulfuric acid.
What happened?
For years, you've been told that the number on the scale defines whether you're healthy or not. You've tried countless hours of cardio.
With some soft metals, this is easy to do, but that was probably because the powder, or about 4,500 Canadian. This was way more than I ever imagined.
So
I'd be
it turned
extracting
from
powder.
the
Considering when he
solid
first pitched it,
into
he just said it was
powder
some
using the
gold-plated
chemical
stuff.
reaction,
However, I was
and
really happy it
then
turned
you
out
see
this
how
way,
it turned
because
into
it made the
gold.
project a lot more fun. But in any case, it didn't really seem to be much of an issue, so I ended up going back to the other one. The gold started melting relatively quickly, and I just kept topping it up with more powder and occasionally with some more borax. When I was eventually done, I was left with this giant blob of gold. I let it cool for a few minutes so that it would solidify, and then I knocked it out of the dish. I dunked it in some water to cool it down quickly, and I also washed it a bit to get rid of any borax residue. The final result was this giant chunk of gold with a mass of 81.31 grams. This was a bit less than the powder that I started with, but that was probably because the powder still had a bit of water. I was able to smash it all the way through.
So when it's actually 100% pure gold, the gold is actually softer. All right, so that's pretty much about gold. Okay, before I end, I still one more thing I need you to do. It's the uses of different types of metals. Where are you? Where is it? Oh no, I accidentally closed it. Okay, let me share the other screen with you. Okay, can you get a piece of paper and just write down these 4 types of metal and what is the uses, properties, no need. Okay, get a piece of paper and write down the table here. Metal. Okay, let's just first start with gold. Metal, gold. Jewelry. Copper, just write wire with it. Gold, jewelry. Copper, wire. Aluminium, can. Steel, just write building. Okay, these are the 4 types of metal that you need to know. That's it. Okay, let me just type in the chat as well. Gold, gold, jewelry. Nice. Used to do wire. All these are the uses of gold, uses of metal, okay? Uses of metal, gold, jewelry, copper, wire. Nice. Aluminium.
Teacher, is it
Yes.
just right? Is it just right you share the screen?
Sorry, what do you say?
I say, is it just right your screen show us?
No, that one too much already. So you just write based on what I typed in the chat.
Is it right you type in chat one?
Yes, correct.
Okay.
Okay. So this is for the question when they ask list 4 types of metal and its uses. Okay, list 4 types of metals and its uses. So it's gold, copper, aluminum, steel, and its uses. Okay, if you're done, just type in the chat. Done.
Teacher, is it right? This already, and we will end the class.
Yes, that's all for today.
My younger sister is waiting after me.
She's like, I'm still eating. What are you eating? What are you eating, Jane?
Chicken burger, hamburger, the hamburger.
Wow, I'm hungry now. So how many teeth have you dropped? 1 or 2? 1 only, is it?
Have 3 burgers.
Okay.
It's only the chicken one.
All right. From McDonald's or something?
No, I don't know, but not McDonald's.
Okay.
My mommy buy it,
Let's see.
and I don't know where she buy.
Okay. All right. So copy done already? All right. So that's all for today's class.
Wait me.
Okay, where are you at? Okay, Jensen, if you're done, you can leave already. See you later after your tea break.
Okay, done.
All right. See ya then. Carol, you good? Done?
Not yet.
Okay.
Teacher, I can't see.
See what? Mainly it's from the chat, that's all. The 4 users and the 4 type of method.